Good morning. This lesson is for my Honors Integrated 1 class and my Integrated 1 class. But before I get started, I want to say I hope that everyone is doing all right out there. I'm not sure what I'm going to title this, but when I title it, I'll tell it what I title it in the title. But what I do know, and I'm sure of, are what my 3 goals are. Our first goal is to consider the converse of congruent triangles having congruent corresponding parts. I tongue twisted myself. Our second goal is to build congruent triangles using what's called the ASA pattern and what this implies. I'll explain what this means when we get to that goal. And our third goal is to build congruent triangles using the SAS pattern and what that implies. I'll explain what this means in a little bit when we talk about our third goal. Alright, so let's go ahead and jump into our first goal. So what I'm trying to say here in this first goal, and I'll say it in a summary, then I'll walk through the lesson, is if I have objects that are identical, 2 identical objects, then what that means is the parts that made those objects must be identical in the same place. Now, instead of starting with identical objects and understanding that the parts must be the same to make the objects identical, let's now start with, I feel like I'm dancing, let's now start with the identical parts in the same place or corresponding places for all the ingredients, all the parts. If I have 2 objects that have identical parts in the same position, right, then that means that the objects as a whole must be identical. So this is what I'm going to try to walk you through, and hopefully I'm able to articulate it. Probably not, but we will see. All right, so our first goal, let's review this. If we have congruent triangles, then the corresponding parts, or then all the corresponding parts are congruent. So if I have identical objects, then what makes those objects must be the same and in the same position, right? So identical objects mean all parts are identical and in the same place. That's what this is saying. Now I want to take the converse of this. I want to switch what I'm starting with. I started with the identical objects, and I ended up with that meant that all the parts had to be identical in the same place. I'm going to switch the order here. I'm going to start with this and end with this, and I think that's a reasonable conclusion. Right? I think that's very reasonable. So the converse of this first statement will be, if all the corresponding parts are congruent, then we have congruent triangles. So if what makes the objects are identical and in the same place, then the objects themselves must be identical. All right? And by the way, math started off as a philosophy. Hopefully you understand that right now. So now we have a second method to determine if figures are congruent. The first was the existence of rigid motions that map the pre-image onto the image. But we have this new criteria if all the parts are corresponding and if all the corresponding parts are identical, if the ingredients are the same and they're in the same position, then that means the whole must be the same, right? And so we now have a second method to determine if our shapes are congruent. So back to our new method of determining if figures are congruent based on all the corresponding parts being congruent. For a triangle, we need to show there are 3 pairs of congruent sides and 3 pairs of congruent angles, all in corresponding positions. We need 6 congruences to determine that triangles are congruent. That's a lot. You know, for a 4-sided shape, you would need 8, but I'll stop right there. Pump the brakes. Fortunately, there are patterns that need only 3 congruences that allow us to determine that triangles are congruent. So I don't need to show that all of the sides are the same, and I don't need to show that all the angles are the same, and that they're all in the same spot. We have shorter methods that require 3 pairs of congruences. So I'm going to go ahead and get into the first pattern, the shorter method that allows me to determine that triangles are congruent, and then I'll get into the second shorter method. And what I'm going to do with this is I'm hopefully going to tie in that previous lesson where I showed you how I could copy a length and copy an angle, because this is when I'm going to use it. So let me go ahead and clean all this off, and I'll be back. I'm back. So let's go ahead and jump into the second goal here, and that's building congruent triangles using an ASA pattern and what this implies. So let's jump into the second goal. Let me have a little bit. All right, so our second goal. Remember, we can copy angles and segment lengths. I want to build an identical triangle by copying an angle, adjacent side, and an adjacent angle. Adjacent's a fancy way to say next to. This is the angle side angle congruence pattern that allows me to conclude we have congruent triangles without showing all 6 congruences. Okay, so I'm going to copy an angle, I'm going to copy the side length next to that angle, and I'm going to copy the angle on the other side of that side length. And then that is the ASA angle side angle congruence pattern. Now let's go through this. Where did I hide my compass that I need for this lesson? There you are, I found you. Okay, so I'm going to copy an angle. I'll copy angle A, side length AC, and angle C onto this. And when I'm done copying it, I've built a triangle that's identical to triangle ABC. Again, I don't need all 6 congruences to have identical triangles. So again, I make an arc, copy the arc, figure out how much my angle opens, copy how much my angle opens. Now I've copied one angle. I'm now going to copy a side length. I'm going to copy side length AC. Copy down to here. Okay. Now finally I'm going to copy angle C. So again, I'm building from scratch identical triangles. I'm so bad at this, going this way, but that's okay. Connect the dots, and I've built identical triangles. Now it's probably going to be off a little bit because I'm using a string and a whiteboard marker that's very wide and not very accurate. But I think those are pretty close to being identical triangles. I've copied it. By copying an angle, the adjacent side, and then the angle next to the side, I can guarantee that I have 2 identical triangles. Okay? And again, I wanted to walk you through the, the building of identical triangles so that you can recognize the pattern. So, for the angle side angle, or the ASA, the congruent sides must be between the congruent angle pairs. We call this included congruent sides. Here's an example. Oh, email. Here's an example. Try this example and hit pause. Which triangles are congruent because of the angle side angle congruence? If congruent, write a congruent statement. So which of these triangles, triangle 1, triangle 2, and triangle 3, which of these are congruent? Hit pause, try it on your own, and see if you can come up with the answer that I come up with. I hope you hit pause. If you don't try, you don't learn. All right, so triangle 1 and triangle 3 are congruent. Because of the angle side angle pattern. That's not included. That's not between the congruent angles. So because triangle 1 and triangle 3 are congruent by angle side angle, I can write my congruent statement. So I can write the name of the first triangle, triangle ACB, and that must be congruent. Remember, they have to go by corresponding. So I went 1 congruent mark, no congruent mark, 2 congruent mark. 1 congruent mark, no congruent mark, 2 congruent mark. So that must be congruent to triangle JIH. All right, and from there I can list my congruent corresponding parts, and that's what this implies. So I'm going to actually write that out here from the previous. So I'm going to continue this on when I come back and finish this second goal. But again, I wanted to show you that I can build identical triangles by copying an angle, its side, and then the angle on the other side of that side. So let me clean this up, and we'll move on to the third goal here, and maybe try and think what the SAS pattern is going to entail, what we have to do in order to copy or build identical triangles. So let me go ahead and clean all this up, and I'll be back. I don't know why I just put it this way. I'm back. So let's go ahead and continue our second goal and finish our second goal. I was thinking about this and I was not happy with how I explained why triangle 2 is not congruent to triangle 1 and 3. So I'd like to elaborate a little bit on that. So triangle 2 wasn't congruent to triangle 1 and triangle 3 because in triangle 2, the congruent side, which was side DF, was not between the two congruent angle pairs. It was outside of it. That means it's not included. That means it's not angle side angle. All right, remember the congruent side must be between the congruent angles. Back to our two triangles that were congruent though, triangle ACB and triangle JIH. We now have a congruent statement, so we can list congruent corresponding parts. And this is what I mean when I'm talking about what it implies. Because I have congruent triangles, I can now list the congruent corresponding parts. So I know what other parts of the triangles are congruent because those three parts following that pattern were congruent. All right, so I can say angle A is congruent to angle J. I can also say that angle C is congruent to angle I. And I can finally say about my angles, angle B is congruent to angle H. For my sides, I know that side AC is congruent to side JI. I know that side CB is congruent to side IH. And finally, I know that side BA is congruent to side HJ. And this is what we get from the congruent corresponding parts. So we're going to start to see a structure. Determine if the triangles are congruent. List the congruent corresponding parts. What can we say after that happens? So we're going to start to build a structure for an argument. Okay, and we'll get into that a little bit more, but right now we're just learning about the patterns. So keep that in the back of your mind. All right, so I'm going to check off the second goal, and we're going to move on to the third goal. And our third goal is to build congruent triangles using the SAS pattern. And that stands for the side angle side pattern and what this implies. Guess what? It implies the same thing. All right. So we can build a triangle. We can build congruent triangles. We can build I'm so bad at grammar. We can build a congruent triangle to an existing triangle if we copy a side length, adjacent angle, and another adjacent side to the copied angle. This is the side angle side or SAS triangle congruent pattern that guarantees we have congruent triangles. So I'm going to build an identical triangle to this down here by copying it on the line J at point S by doing the following. By copying segment LN, angle N, and side or segment NM, we will have constructed a triangle congruent to triangle LMN by side angle side. So let's go ahead and build this. Where did I have I hit it right there. All right. Here we go. Let's copy a side length. LM. LN. Let me learn my letters. You are that long. You are that long. Let me copy angle N. Cricket's back. Not ready to marker anymore. And let me copy the length of it. MN. NN. MN. 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 Getting late. Friday at 5:30. 5:20. I'm ready to go home. Alright, so let me copy this length. Come down here and copy it. And by me connecting this point to this point, I've built a congruent triangle to my triangle by the side angle side pattern. they're pretty close to being identical. Not bad, not bad, not bad at all. All right, so I'd like to formalize what we're looking for with side angle side, formalize what we're looking for with angle side angle, and then just wrap up this whole lesson, all right? So hopefully I've convinced you that if I copy a side length, an angle, and a side length, I've created a identical triangle. By the way, the angle that I copied is an included angle. And it's included because it's between, right? The segment was included because it was between the congruent angles. This angle is included because it's between the congruent sides. So hopefully that's that idea is sticking with you here. Write that down. I didn't write it down, but you should write it down. All right, so let me clean this up, summarize this entire lesson, and I'll be back. I'm back for the last time, I promise. Let's go ahead and just summarize what this lesson was about. So remember, we started off with the idea of having congruent triangles, which meant all the parts in the same position must be congruent. We switched the order of that statement and started off with two shapes that have all the parts are congruent and in the same position, which meant that the full objects, the triangles themselves, must be congruent. So we needed 6 congruences to be in the same position in order to state we had congruent triangles. Fortunately, somebody along the way discovered that you don't need all 6, you just need a pattern of an angle, an included side, and the other angle, or a side, the included angle, and the other side. I hope that I convinced you by building these triangles using the constructions that the previous lesson was about, that I could build identical triangles by just building those 3 parts in that specific order. If we don't have that specific order, it's not good enough to say they're congruent. Okay, it has to be in that order, no exceptions. All right, so again, I hope that this is making sense to you. The angle side angle, or ASA congruence pattern, is the following. 2 pairs of congruent angles with a congruent included side. This means the triangles are congruent, so we can write a congruent statement and list the corresponding congruent parts. This is what it implies, this part. We can go one step beyond the congruent triangles. Side angle side, or SAS triangle congruence pattern. 2 pairs of congruent sides with the included congruent angle. This means the triangles are congruent, so we can write a congruent statement and list the congruent corresponding parts. That is what that implies. Alright, that's it. The next lesson that I need to talk about, I'm going to talk about hidden congruences. Congruences hidden in plain sight. Alright, so I hope this all makes sense to you. I hope that I was able to achieve my goals. Again, I hope everyone is doing all right out there. Have a great day, everybody. Bye-bye. I said it right this time. Good job.